Welcome to AWS Certified Cloud Practitioner Certification 2024 Complete Training. Hi, I'm Vivin Arana and I will lead this training. In this particular training, we are going to look at complete training session which starts with section 1 where we're going to talk about AWS Certified Cloud Practitioner Certification. It covers overview of the certification, exam details and structure, preparation resources, and exam registration and tips. From there, we'll go to section 2, which gives you an introduction of AWS. It talks about the overview of cloud computing and introduction to AWS. In section 3, we will cover AWS core services. We talk about the compute services like EC2 and others, storage services like S3 and others, and then networking services like VPC. From there, we're going to jump into section 4, which is focused on security and compliance. It's about AWS Security Fundamentals. We're going to talk about compliance and governance, and we're going to talk about AWS Well-Architected Framework. Next, in section 5, we will cover AWS pricing and support, where we will look at different AWS pricing models. We will look at AWS billing and cost management, and finally, AWS support plans. In section 6, we're going to talk about AWS cloud architecture, which covers cloud architecture basics, how to design for the cloud, and AWS Global Infrastructure. In section 7, we're going to talk about AWS Cloud Adoption Framework, which is CAF, where we will look at what AWS Cloud Adoption Framework is, and then planning and implementing AWS CAF. In the last section, section 8, we're going to start with preparation and practice, where we will talk about the practice exams and quizzes you can take. Next, review and study strategies that you need to use, and final review session before you sign up for your AWS certification course and test. Our first section talks about AWS Certified Cloud Practitioner Certification. Here, we will go over first the overview of the certification. In that, we'll look at the purpose and audience of the certification. The purpose is the AWS Certified Cloud Practitioner certification is designed to validate a candidate's overall understanding of the AWS cloud, independent of specific technical roles. It is aimed at providing foundational cloud knowledge that can serve as a stepping stone to more advanced AWS certifications. The audience we're targeting are individuals new to the cloud, especially those in non-technical role, example sales, marketing, project management, who need to communicate effectively about AWS cloud services. IT professionals and students looking to gain a foundational understanding of AWS before pursuing more technical certifications. Also, business stakeholders and executives interested in understanding the potential benefits and opportunities of cloud adoption. What are the benefits of earning the certification? First, credential recognition. It demonstrates a foundational understanding of AWS cloud concepts, which is increasingly important in today's technology driven job market. Career advancement. It opens up new job opportunities and career paths, particularly in cloud related fields. Pathway to advanced certification. It serves as a stepping stone to more advanced AWS certifications like AWS Solutions Architect Associate, AWS Developer Associate, and AWS SysOps Administrative Associate. And improved communication. It enables better communication and collaboration between technical and non-technical teams with an organization by providing a common understanding of cloud concepts. Let's go over the exam details and structure. So first we'll cover the exam format, which is number of questions and type of questions. The number of questions, the exam typically consists of 65 questions. The question types are multiple choice, where you select one correct answer from 4 options, or multiple response, where select 2 or more correct answers from 5 or more options. The exam duration for candidates is 90 minutes, where you have to complete the exam. This exam is available in multiple languages including English, Japanese, Korean, and simplified Chinese. The domains covered or the knowledge areas and weightage is first domain where which covers the cloud concepts, which is 26%, where you need to have an understanding of basic cloud concepts and the AWS cloud value proposition. Also the knowledge of key AWS services and their common use cases. Domain 2 is the security and compliance, which covers 25%. So, where you need to have an understanding of the AWS shared responsibility model, AWS security and compliance concepts and resources, and AWS identity and access management IAM features and best practices. The domain 3 is technology, which is the most weighted domain, which is 33%, where you need to know about the core AWS services, including compute, networking, databases, and storage, AWS Global Infrastructure and architectural principles, and understanding of cloud deployment and operation concepts. Domain 4 covers billing and pricing, which is 16%, where you need to know about AWS billing and pricing models, cost management, account structures, and billing tools, and AWS support plans and resources available for cost optimization. What is the passing score needed and what is the time allocated? So the passing score for the AWS Certified Cloud Practitioner exam is typically around 700 out of the 1000 points. However, the exact passing score can vary as AWS uses a scaled scoring system. Next is the time allocated. You have 90 minutes to complete the exam, which is generally sufficient given the questions count and content complexity. What are the preparation resources that you would need? Official AWS study materials. So there are AWS Cloud Practitioner Essentials. This is a fundamental course offered by AWS Training that covers all the topics needed for the exam. It includes video lectures, demonstrations, and hands-on labs. You can also use this video as a starting point, and this video itself is sufficient to pass the exam. There's also some AWS white papers you can look at. Key white papers include the AWS Well-Architected Framework, overview of Amazon Web Services, and how AWS pricing works. These documents provide in-depth insights into best practices, services, and pricing. There's also an exam guide. AWS provides a downloadable exam guide that outlines the domain's objectives and sample questions for the exam. So based on all these resources, I've prepared this video series where you can learn everything at one single place here, and then you don't have to access any of these. But if you want more direct from the source, you can use any of these resources. Some of the recommended books, courses, and practice exams, if you want to look at more items, is if you're a book person, there's that AWS Certified Cloud Practitioner Study Guide by Ben Piper and David Clayton, which provides a comprehensive review of exam topics. There's also some online courses on platforms like Coursera, Udemy, Cloud Guru offered structured learning paths with video content, quizzes, and hands-on labs. And there's practice exams. Taking practice exams is crucial for understanding the question format and timing. AWS and third-party providers like WizLabs and Exam Pro offer practice exams. If you're someone who wants to get this done quickly and easily, you can just stay on this video series and you will have everything that you need for the exam. Some of the exam registration and tips include how to register for the exam. Now, AWS training and certification portal is available for you where you can register for exam via the AWS training and certification portal. The exam can be taken at a Pearson VUE or PSI testing center or online via a proctored exam. Registration steps include if you can go into your AWS certification account. If you don't have one, you can create one. Choose the AWS Certified Cloud Practitioner exam over there, select a testing center or the online proctoring option, and pay the exam fee, which is around 100 US dollars, and then schedule a date and time for the exam. Some of the tips for the exam day, what to expect and how to prepare. Before the exam, for rest and relaxation. Ensure you are well rested before the exam. Avoid last minute cramming to keep your mind fresh. Review the key concept. Do a light review of key concept, focusing on areas you may feel less confident in. You can take those notes while you're going through this video. During the exam, three things to take care of is time management. Allocate time per question and flag any difficult questions for review at the end. Read everything carefully. Ensure you fully understand the questions and answers before selecting an option. And stay calm. Manage exam stress by taking deep breaths and stay focused on the questions. If you have an anxiety attack or something, just make sure that you take a bag so you can breathe in, breathe out. After the exam, review the results. After completing the exam, you'll receive preliminary results. Final scores are typically available within a few days. And then plan the next steps. If you pass, celebrate your achievement and consider your next certification. If not, review your weak areas and prepare to retake the exam. Come back to this video and leave notes how the exam went. This deep dive into the first section provides a thorough understanding of what the AWS Certified Cloud Practitioner certification entails, how to prepare for it, and what to expect during the exam process. So let's jump into Introduction to AWS. Section 2, Introduction to AWS. In this, we will first look at overview of cloud computing. So let's look at the definition and benefits of cloud computing. For definition, cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of owning and maintaining physical data centers and servers, organizations can access technology services such as computing power, storage, and databases as needed from a cloud provider like AWS. Benefits of this include cost efficiency, which reduces the capital expense of buying hardware and software, setting up and running on site data centers. Scalability provides the ability to scale computing resources up or down according to business needs without upfront commitments. Speed and agility allows for rapid provisioning of resources, enabling faster time to market for products and services. Global reach offers the ability to deploy applications in multiple regions around the world, ensuring low latency and high availability. Security provides comprehensive security capabilities that exceed traditional on prem environments. What are different types of cloud computing? We have public, private, and hybrid. The public cloud is where services are delivered over the public internet and shared across multiple organizations. Examples like AWS, Microsoft Azure, and Google Cloud Platform. Then we have the private cloud, where cloud infrastructure is operated solely for a single organization. It can be managed by the organization or a third party and may exist on prem and off prem. Hybrid cloud, a combination of public and private clouds that allows data and applications to be shared between them. Organizations use hybrid clouds to achieve a balance between deploying critical workloads in private clouds and leveraging the scalability of public clouds. Cloud service models, there's three of them: IaaS, PaaS, SaaS. The first one, infrastructure as a service, provides virtualized computing resources over the internet, such as virtual machines, storage, and networks. AWS services like Amazon EC2 and Amazon S3 fall under this category. Platform as a service, or PaaS, offers a platform allowing customers to develop, run, and manage applications without worrying about the underlying infrastructure. Examples include AWS Elastic Beanstalk and AWS Lambda. And then there is SaaS, which is software as a service, which delivers software applications over the internet on a subscription basis. Customers access software hosted on the cloud, such as AWS Workspaces and Amazon WorkDocs. Let's dive into Introduction to AWS. Now, what is AWS? Amazon Web Services, AWS, is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services from data centers globally. AWS is used by millions of customers, including the largest enterprises, startups, and government agencies, to lower the cost, become more agile, and innovate faster. Let's talk about the AWS evolution. It was launched in 2006 when AWS started with services like Amazon S3, which is simple storage service, and Amazon EC2, which is Elastic Cloud Compute Cloud. Over time, AWS has expanded its portfolio to include services in artificial intelligence, machine learning, Internet of Things, and much more. Global infrastructure, regions, availability zones, and edge locations. Let's dive into regions. AWS regions are geographic areas where AWS has multiple isolated locations known as availability zones. Each region is designed to be completely isolated from the others to achieve the greatest possible fault tolerance and stability. Availability zones or AZs. AZs are distinct locations within a region engineered to be isolated from failures in other AZs. They provide low latency networking between each other and can be used to run applications and databases that are highly available, fault tolerant, and scalable. Edge locations. AWS edge locations are data centers located in major cities around the world where AWS caches copies of content for faster delivery to end users. This is a key component of AWS's content delivery network, also called a CDN service, which is Amazon CloudFront. Let's look at the key AWS services overview, which is compute, storage, and networking. Now, the compute services include the Amazon EC2, which provides resizable compute capacity in the cloud, allowing you to launch virtual servers with a variety of operating systems and configurations. You have AWS Lambda, which lets you run code without provisioning or managing servers. You pay only for the compute time you consume. And then we have Amazon ECS and EKS, which manage containerized applications using Docker. ECS, which is Elastic Container Service, is a highly scalable container orchestration service, while EKS, which is the Elastic Kubernetes Service, provides Kubernetes as a managed service. Let's look at some of the storage services, which is Amazon S3, a scalable object storage service used for storing and retrieving any amounts of data from anywhere on the web. Then we have the Amazon EBS, which provides block storage volumes for use with Amazon EC2 instances. EBS volumes are automatically replicated within their availability zone. And finally, we have the Amazon Glacier, offers secure, durable, and extremely low cost cloud storage for data archiving and long term backup. Let's look at network services. We have Amazon VPC, which is Private Cloud, enables you to provision logically isolated sections of AWS cloud where you can launch AWS resources in a virtual network that you define. We have Elastic Load Balancing ELB, which automatically distributes incoming application traffic across multiple targets such as EC2 instances, containers, and IP addresses. We also have the Amazon Route 53, a highly available and scalable domain name system DNS web service designed to route end users to internet applications by translating human readable names into the numeric IP addresses that computers use to connect to each other. Now, this particular section provided a detailed introduction to AWS covering essential cloud computing concepts and the foundational AWS services, which are critical for anyone preparing for the AWS Certified Cloud Practitioner certificate. Next section, we're going to look at AWS core services. Section 3, we're going to talk about AWS core services. First, we'll cover some of the compute services. First one being Amazon EC2, which is Elastic Compute Cloud. Amazon EC2 provides scalable computing capability in the cloud, allowing users to launch virtual servers called instances. It supports various instance types optimized for different use cases like compute intensive or memory intensive workloads. Let's talk about the EC2 pricing models. There's on-demand instances where you pay for compute capacity by the hour or second with no long-term commitments. Next, we have the reserved instances where you provide a significant discount compared to on-demand pricing, suitable for steady-state workloads where the usage can be predicted. We have the spot instances, allows you to bid on spare EC2 in capacity, offering up to 90% cost savings compared to on-demand prices. Best for flexible workloads that can handle interruptions. Then we have the savings plan, which has flexible pricing model offering lower prices in exchange for a commitment to a consistent amount of usage measured in dollars per hour for a 1 or 3 year term. Let's look at the different instance types. Instance types include general purpose, which is balanced compute, memory, and networking. Example T3, M5 instances. We have the compute optimized, which are the high performance processors for compute intensive tasks. Example C5 instances. We have the memory optimized, which are high memory for memory intensive applications. Example R5 or X1 instances. Then we have the GPU instances, which are designed for machine learning and high performance computing. Example P3 or G4 instances. Next, AWS Lambda. Now, AWS Lambda is a serverless compute service that allows you to run code without provisioning or managing servers. You only pay for the compute time consumed, making it ideal for short-lived or event-driven workloads. Use cases for this include the event-driven applications that automatically run code in response to events, example file uploads to Amazon S3, updates in DynamoDB, and serverless backend where you can build backend APIs or microservices without managing the underlying infrastructure. Benefits of Lambda include it's cost effective, only pay for the execution time with no charge when your code is not running. Scalability. Lambda automatically scales based on the number of requests, handling from a few to thousands of concurrent requests. Amazon EC2, also called as the Elastic Container Service, and Amazon EKS, which is the Elastic Kubernetes Service. Let's look at Amazon ECS. It's fully managed container orchestration service that supports Docker containers. It enables you to easily run, scale, and secure containerized applications in production. What about Amazon EKS? It's managed Kubernetes service to run Kubernetes applications without needing to manage the Kubernetes control plane. Use cases include microservices architecture, simplify the management of containerized microservices across clusters, batch processing, scale containerized batch jobs across an EC2 cluster. Let's look at storage services next, where we have the Amazon S3, which stands for Simple Storage Service. Amazon S3 is scalable object storage service that allows you to store and retrieve any amount of data from anywhere on the web. It's designed for high availability and durability. By 99.9999, we have 11 nines in here just to show how durable it is. The key features include storage classes. S3 offers multiple storage classes to optimize cost based on access patterns. S3 standard for frequently accessed data. We have the S3 intelligent tiering automatically moves data between two access tiers where access patterns change. S3 Glacier for archival storage with low cost storage for data that's rarely accessed. Versioning and lifecycle policies protects against accidental deletions by enabling object versioning. Lifecycle policies can automate transitioning objects to cheaper storage classes or deletion after a specific period. Security. S3 integrates with AWS IAM and uses encryption methods such as server-side encryption, either SSE S3 or SSE KMS, to secure stored data. Use cases include data lakes, store large volumes of structured and unstructured data for analytics and machine learning. Can be used for backup and restore. Store backup data securely, and retrieve it when needed. Then we have static web page hosting. Host static content HTML, CSS, JavaScript directly from S3. Amazon EBS or Elastic Block Storage. Amazon EBS provides persistent block storage volume for use with EC2 instances. EBS volumes are replicated within an availability zone for durability. Some of the key features include the volume types, where general purpose SSD, GP3, it balances price and performance for a wide variety of workloads. We have the provisioned IOPS SSD, which is IO2. It's high performance SSDs designed for input output intensive applications like databases. We have the throughput optimized HDD, which is HT1, low cost HDD for frequently accessed throughput intensive workloads. And we have the cold HDD SC1, which is lowest cost storage for infrequently accessed workloads. We can also do snapshots where backups EBS volumes to Amazon S3 using EBS snapshots. Snapshots can be used to create new volumes or restore data to an existing volume. Use cases include the relational databases where you can store transactional data with low latency requirements. We have enterprise applications which supports high performance workloads with a large number of IOPs. Amazon Glacier. Amazon Glacier is a low-cost storage service designed for data archiving and long-term backups. It's ideal for data that is rarely accessed but needs to be retained for long periods. Retrieval options: expedited, standard, and bulk. In expedited is a quick retrieval within minutes for urgent access to archive data. Standard is retrievals typically complete within 3 to 5 hours. In the bulk, retrieval takes up to 12 hours but are the most cost effective. Use cases include archival of legal and compliance documents, long-term retention of infrequently accessed data. We have media asset storage, storing large media files that need to be preserved but not frequently accessed. Let's look at networking services. First, Amazon VPC, which is Virtual Private Cloud. Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. VPC allows control over the networking environment, including IP address ranges, subnets, route tables, and gateways. Some of the key features include it has subnets, logical partitions within a VPC, enabling segmentation of resources. Internet gateways and NAT gateways controls how instances within a VPC communicate with the internet. And finally, we have the security groups and network ACLs, which control the inbound and outbound traffic to your instances and subnets. Use cases include hosting websites. Securely host websites or applications by controlling traffic flow between public and private subnets. You have the hybrid cloud connectivity, where connect on-prem data centers with AWS resources through VPN or Direct Connect. Elastic Load Balancing or ELB. ELB automatically distributes incoming application traffic across multiple targets, whether it be EC2 instances, containers, or IP addresses, to ensure high availability and fault tolerance. Type of load balancers include application load balancer, also called as ALB, operates at the application layer HTTP HTTPS and is used for advanced routing and microservices architecture. You have the network load balancer, which is NLB, operates at the transport layer TCP and is used for ultra low latency and high throughput applications. And we also have the classic load balancer, which operates at both the application and transport layers but is legacy and used less frequently. Use cases for this include scaling applications, automatically balance traffic across instances to avoid bottlenecks and ensure performance. Next, Amazon Route 53. Amazon Route 53 is a highly available and scalable domain name system (DNS) web service designed to route end users to internet applications by translating human readable names like www.example.com into IP addresses that computers use to connect to each other. Key features include domain registration, register domain names, and manage DNS records through Route 53. Into traffic routing, route traffic to AWS resources or external endpoints with policies such as latency based routing, geolocation routing, and failover routing. Have health checks, continuously monitor the health of your applications and automatically route traffic to healthy endpoints. Use cases include global application hosting, route traffic across AWS regions for global applications with low latency access. For disaster recovery, enable failover to backup resources in case the primary resources fail. This deep dive into the AWS core services in this video gives you a thorough understanding of the foundational AWS services, their use cases, and key features. These are critical components of the AWS Certified Cloud Practitioner exam. Next, we're going to look at security and compliance. Section 4, Security and Compliance. In this particular section, we're going to look at first AWS Security Fundamentals. What is shared responsibility model? The AWS shared responsibility model outlines the division of security responsibilities between AWS and the customers. What is AWS's responsibility or security of the cloud? AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud. This includes the hardware, software, networking, and facilities that run AWS cloud services. AWS also manages security controls for services like database encryption, hardware security modules which is HSMs, and the physical security of data centers. What is customers' responsibility or security in the cloud? Customers are responsible for securing the data and applications they store in AWS. This includes data encryption, access management, patching operating systems, configuring network security, and managing IAM, identity and access management policies. Customers must also ensure that applications are securely configured and that they monitor and audit their AWS resources regularly. AWS Identity and Access Management IAM. IAM enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow or deny access to AWS resources. Some of the key concepts include users, which represents a person or service that interacts with AWS services. Then there's groups, which is collections of IAM users. Users in a group inherit permissions assigned to the group. Roles allows you to delegate access to users or services without sharing long-term credentials. Roles can be assumed temporarily by users or services. Policies documents that define permissions. Policies are attached to users, groups, or roles and dictate what actions they can perform on which resources. What are some of the best practices? First one, least privilege principle. Grant only the permissions necessary for users to perform their task. Use multi factor authentication or MFA. Add an extra layer of security by requiring a second form of authentication. Rotate credentials regularly. Implement policies to rotate access keys and passwords to reduce the risk of compromised credentials. Let's look at security groups and network ACLs. What are security groups? Security groups act as a virtual firewall for your EC2 instances to control inbound and outbound traffic. Security groups are stateful, meaning if you allow an incoming request, the outgoing response is automatically allowed. Configuration, you can specify rules based on IP addresses, CIDR blocks, and ports. By default, security groups deny all inbound traffic and allow all outbound traffic. Some of the use cases include Secure access to EC2 instances by restricting inbound traffic to specific IP addresses or ranges. Allow or deny traffic to and from specific application tiers within a multi tier architecture. Network ACLs or access control lists. So, network ACLs provide an additional layer of security at the subnet level within a VPC. Unlike security groups, network ACLs are stateless, meaning that responses to allowed inbound traffic must be explicitly allowed through outbound rules. Configuration: you can define both inbound and outbound rules with the ability to allow or deny traffic. Rules are processed in order from lowest to highest, and the first rule that matches a traffic type is applied. Some of the use cases include provide an additional layer of security by controlling traffic at the subnet level, implement specific rules for subnet traffic that complement or override security group rules. Next, look at compliance and governance. AWS compliance programs and frameworks. AWS compliance programs help customers meet specific regulatory and industry requirements. AWS maintains various certifications and third party attestations that validate the implementation of security controls and adherence to industry's best practices. Some of the key compliance programs include SOC 1, SOC 2, SOC 3. These reports on controls relevant to security, availability, processing integrity, confidentiality, and privacy. Then there's ISO 27001, 27017, 27018. These are international standards for information security management and cloud specific security. Then we also have PCI DSS, Payment Card Industry Data Security Standard, applicable to services handling credit card transactions. We also have HIPAA, which is Health Insurance Portability and Accountability Act, which sets the standard for protecting sensitive patient data. AWS Artifact, it's a self service portal that provides on demand access to AWS's compliance documentation, including audit reports, compliance certifications, and security information. AWS Compliance Enablers, there's AWS Config, which provides continuous monitoring and record keeping of AWS resource configurations, enabling governance, compliance, and operational auditing. We also have the AWS Cloud Trail, which enables governance, compliance, and operational and risk auditing of your AWS account by logging AWS API calls and changes to your resources. AWS Artifact and AWS Organizations. AWS Artifact is your go to central resource for compliance related information, providing access to AWS's security and compliance reports. Accessing reports. You can download SOC reports, ISO certifications, and other documents to assist with your compliance requirements. Use cases involve useful for auditors, compliance officers, and security professionals who need evidence of AWS's compliance with specific standards. AWS organizations. AWS organizations is a service for consolidating multiple AWS accounts under a single management umbrella. It enables you to create policies to manage your accounts and control access to services. Some of the key features include service control policies, which is SCPs, define the maximum available permission for all accounts in your organization, enforcing policies that are consistently applied across accounts. Consolidated billing. It simplifies billing by aggregating costs across multiple AWS accounts, offering potential cost savings and easier tracking of expenses. Use cases include ideal for enterprises managing multiple AWS accounts, allowing central control of access and billing across departments, subsidiaries, or projects. Let's look at AWS Well-Architected Framework. There are multiple pillars, and the first one is the security pillar overview. The AWS Well-Architected Framework provides best practices for designing and operating reliable, secure, efficient, and cost effective systems in the cloud. The security pillar focuses on protecting data, systems, and assets through risk assessments and mitigation strategies. Some of the key concepts in security pillar include identity and access management. Implement the principle of least privilege, ensure strong authentication and authorization, and manage identities effectively. Then there is detective controls, establish mechanisms to identify security misconfigurations or breaches, including monitoring, logging, and auditing. Infrastructure protection, protect networks and systems, including perimeter controls, encryption, and secure configurations. Data protection, secure data at rest and in transit using encryption and other mechanisms to ensure data integrity and privacy. Incident response, prepare and regularly exercise an incident response plan to mitigate the impact of security breaches. Let's talk about the key security best practices. Data encryption, always encrypt sensitive data at rest and in transit using AWS's encryption services like AWS Key Management Service, also called as KMS, and AWS Certificate Manager. Regular audits and compliance checks. Continuously monitor and audit your AWS environment using tools like AWS Config, AWS CloudTrail, and AWS Security Hub to ensure compliance with security policies. Least privilege access. Limit permissions to only what is necessary for users and applications to perform their task, reducing the risk of accidental or malicious data exposure. Automated security management. Implement automated security controls using AWS services like AWS config rules and Amazon Guard Duty to detect and respond to security events in real time. This video provided a detailed overview of AWS security and compliance, essential for ensuring that your AWS environment is secure and meets necessary regulatory requirements. These topics are critical for the AWS Certified Cloud Practitioner exam and for building a secure and compliant cloud infrastructure. Next, we're going to look at AWS pricing and support. Section 5, AWS pricing and support. Let's look at different AWS pricing models. First, pay as you go. The pay as you go pricing model allows customers to pay only for the resources they consume without upfront commitments. This model provides flexibility, enabling you to scale your usage up or down based on demand. Advantages of this is cost efficiency. You avoid the capital expense of buying hardware and software and only pay for what you use. The flexibility advantage where easily scale your usage based on business needs, avoiding over provisioning and underutilization. Examples include Amazon EC2 instances built by the hour or second, Amazon S3 storage charged per gigabyte used. Reserved instances. Reserved instances or RIs provide a significant discount up to 75% compared to on demand pricing in exchange for committing to one or 3 year term. This model is ideal for workloads with predictable usage. Types of reserved instances include standard RIs, offer the most significant discount and are best suited for steady state workloads. Convertible RIs provide some flexibility to change instance families, operating system, and tenancies during the term with a lower discount than standard RIs. Scheduled RIs available for purchase to reserve capacity for recurring schedules. What are the advantages? Cost savings, substantial discounts for long term usage. Predictability, ideal for workloads with predictable resource usage. And then there are spot instances. Spot instances allow you to bid on unused EC2 capacity, offering up to 90% savings compared to on demand prices. These instances can be terminated by AWS when the capacity is needed for on demand instances, making them suitable for flexible, fault tolerant workloads. Use cases include batch processing, run large scale batch jobs at a lower cost, big data analytics, cost effectively process large data sets, CI/CD pipelines, use spot instances to perform builds and tests at a fraction of the cost. Advantages include deep discounts, significant cost savings for workloads that can handle interruptions. Scaling. Quickly scale compute capacity based on availability and price. Savings plans. Savings plans offer flexible pricing models that provide up to 72% savings on AWS compute usage in exchange for a commitment to a consistent amount of usage measured in dollar per hour for a 1 or 3 year term. Unlike reserved instances, savings plans apply to usage across different compute services like EC2, Fargate, and Lambda. Types of savings plan include compute savings plans and EC2 instant savings plans. Compute saving plans offer the most flexibility by applying across EC2 instances regardless of region, instance family, operating system, or tenancy. They also apply to Fargate and Lambda usage, whereas EC2 instance savings plans apply to specific instance families within a chosen region, providing higher savings but less flexibility compared to compute savings plans. Advantages include for flexible savings, apply savings across different services and regions, and predictable cost helps in planning and budgeting cloud expenses. AWS billing and cost management. Billing dashboard overview. The AWS billing dashboard provides a comprehensive view of your AWS account's billing and usage. It allows you to monitor costs, view detailed billing information, and manage payment methods. Some of the key features include the Cost Explorer, which lets you visualize and analyze your costs and usage over time. You can filter and group data by service, region, or linked accounts to identify spending patterns and optimize costs. Budgets. Create custom budgets to monitor your costs and usage. AWS budgets can send alerts via email or SMS when your spending exceeds predefined thresholds. Payment methods. Manage payment methods and billing information directly from the dashboard. Use cases include cost monitoring. Regularly monitor your AWS spending to avoid unexpected charges. Budgeting. Set budgets to ensure your spending stays within limits. Consolidated billing and AWS organizations. AWS Consolidated Billing is a feature of AWS organizations that allows you to consolidate billing across multiple AWS accounts. This simplifies tracking expenses and can lead to cost savings through volume discounts. Key features include single bill, receive one bill for all accounts in your organization, simplifying financial management. Cost allocation tags. Use tags to categorize and track cost by project, department, or cost center. Volume discounts. Benefit from aggregated usage across accounts which may qualify for tiered pricing discounts. Use cases include enterprise account management. Simplify billing for organizations with multiple departments or business units using separate AWS accounts. Cost optimization. Maximize savings through volume discounts and cost allocation. AWS support plans. Let's look at the overview of AWS support plans. First, basic support. Included with all AWS accounts at no additional charge, basic support provides access to customer service, documentation, and AWS Trusted Advisor for some checks. Features include 24/7 customer service, access the AWS customer service for billing and account support, AWS Trusted Advisor, limited access to core checks for cost optimization, security, and performance. Use cases for this include is ideal for individuals or small organizations using AWS for testing or development environments. Developer support. Developer support is designed for customers using AWS in non-production environments. It includes technical support and guidance for development and test environments. Features include business hours email support, access to cloud support associates during business hours, general guidance, best practices, client side diagnosis, and architecture support for development use cases. Cost is starting at $29 per month. Use cases suitable for small businesses or startups focusing on development and testing on AWS. Then there's business support. Business support provides 24 by 7 access to AWS support engineers, helping organizations running production workloads on AWS. It includes faster response times and additional trusted advisor checks. Features include 24 by 7 phone, chat, and email support, access to your cloud support engineers for troubleshooting and guidance. AWS Trusted Advisor, full access to all trusted advisor checks, including cost optimization, security, and fault tolerance. Then there's AWS Personal Health Dashboard. It provides alerts and remediation guidance when AWS is experiencing events that might impact your account. Cost starts from around $100 per month or a percentage of monthly AWS usage. Use cases ideal for medium to large businesses with production workloads that require high availability and technical support. And then there's enterprise support. Enterprise support is tailored for large organizations that require dedicated support, technical account management, and deep integration with AWS experts. It provides the highest level of support available from AWS. Features include a technical account manager or TAM, which is assigned to provide proactive guidance and advocacy. We have well architected reviews, regular reviews of your architecture to ensure best practices. Infrastructure event management, dedicated planning and support for large scale events like product launches or migrations. Cost based on the percentage of your monthly AWS usage, typically higher than business support. Use cases include large enterprises with medium to critical workloads that require continuous engagement with AWS. AWS Trusted Advisor and AWS Personal Health Dashboard. Now let's first look at AWS Trusted Advisor. It's an online resource that provides real-time guidance to help you provision your resources following AWS best practices. It offers checks and recommendations in 5 categories: cost optimization, performance, security, fault tolerance, and service limits. The key features include cost optimization. It identifies opportunities to reduce costs such as underutilized resources or outdated pricing plans. Security. Ensure your environment follows security best practices, including checking for open ports and unused IAM roles. Performance. Improve the performance of your AWS environment by optimizing instance types, load balancer, and other resources. Fault tolerance. Enhance the reliability of your applications by identifying single points of failure and ensuring data redundancy. Service limits. Monitor usage against AWS service limits to avoid unexpected disruptions. Let's look at AWS Personal Health Dashboard. Now, AWS Personal Health Dashboard provides alerts and remediation guidance when AWS experiences events that might impact your environment. It delivers a personalized view of the health of AWS services, resources, and accounts. Key features include personalized alerts, get notifications for issues that specifically affect your AWS resources and services, health events, detailed information about ongoing and upcoming events that may impact your resources, remediation guidance, recommendations and steps to mitigate the impact of AWS service disruptions. Now, this video provides a detailed overview of AWS pricing models, billing and cost management, and support plans. Understanding these aspects is crucial for effective cloud financial management and ensuring you have the appropriate support level for your business needs. These topics are also key components of AWS Certified Cloud Practitioner exam. And next topic that we're going to cover is the AWS Cloud Architecture. Section 6, AWS Cloud Architecture. The cloud architecture basics consists first of overview of AWS architecture. AWS Cloud Architecture refers to the design of systems, networks, and applications deployed on AWS, ensuring they meet the requirements for availability, scalability, security, and cost efficiency. Some of the key components include the compute, which is Amazon EC2, Lambda, Elastic Beanstalk. Then we have this for storage, Amazon S3, EBS, and Glacier. For networking, we have Amazon VPC, Route 53, and ELB. For databases, we have Amazon RDS, DynamoDB, and Redshift. Some of the common architecture patterns include the multi-tier architecture, the separation of presentation, application, and database layers, often implemented using ELB, EC2, and RDS. Then we have the event-driven architecture, which decouples services and uses AWS Lambda, SNS, SQS to react to changes in data or application state. Then we have the microservice architecture, which uses containerization and services like ECS, EKS, or Lambda to break applications into smaller, loosely coupled components. Understanding the high availability and fault tolerance. High availability, also called as HA, refers to the system's ability to operate continuously without failure for a long time. AWS ensures HA by providing services and infrastructure that supports multi-region and multi-AZ deployments. What are the key concepts? Multi-AZ deployment, spreading resources across multiple availability zones to ensure that an application remains available even if one AZ goes down. Then we have the elastic load balancing, which is ELB, automatically distributes incoming application traffic across multiple targets in different AZs, enhancing fault tolerance. And we have autoscaling, which automatically adjusts the number of EC2 instances based on demand, ensuring that the right amount of resources are always available. Fault tolerance. Fault tolerance is the ability of a system to continue operating properly in the event of the failure of some of its components. The key concepts include redundancy, duplicate critical components of a system to ensure that if one fails, others can take over without affecting the system's performance. You have the backups and snapshots where regularly backup data and take snapshots of instances to restore systems quickly in the event of a failure. And then we have the disaster recovery, where implement strategies such as pilot light, warm standby, or multi-site to recover from major failures or disasters. Designing for the cloud, scalability and elasticity in the cloud. For scalability, it refers to a system's ability to handle an increase in workload by adding resources. The two types of scalability: vertical scaling, where you increase the power, CPU, RAM of an existing instance. And then there's horizontal scaling, where you add more instances to distribute the workload across multiple resources. Examples is scaling an EC2 instance vertically by resizing instance types, and scaling horizontally by adding more instances in an auto-scaling group. Elasticity. Elasticity is the ability of a system to automatically expand and contract its resources as needed, typically in response to changes in demand. Key services include autoscaling, we automatically adjust the number of instances in response to changes in demand. AWS Lambda automatically scales the execution of functions in response to the number of events. Benefits include cost efficiency, only pay for the resources you use, and performance, automatically handle varying levels of demand, ensuring applications remain responsive. What are the principles of cloud native design? Loose coupling, decoupling components so they can operate independently and communicate through APIs or event driven mechanisms. Benefits include increased flexibility, maintainability, and fault tolerance. Examples: using Amazon SQS for messaging between microservices, AWS Lambda for event driven processing. Statelessness: designing systems where components do not store session information between requests, allowing for easier scaling and resilience. Implementation: store session state in external databases like DynamoDB or in memory stores like Redis. Service discovery: automatically detecting and connecting to other services or instances. AWS services like Route 53, AWS App Mesh, and ECS Service Discovery supports this. Benefits include simplifies management of dynamic environments where instances and services frequently change. AWS Global Infrastructure. Now, how to leverage AWS Global Infrastructure for design? There's regions and availability zones. The AWS regions are geographically isolated areas that host multiple availability zones or AZs, which are physically separate data centers within a region. Some of the design considerations to take care is latency. Choose regions close to your users to minimize latency. Data sovereignty. Select regions based on compliance with local data protection regulations. Resilience: distribute workloads across multiple AZs to ensure high availability. Edge services and content delivery. Amazon CloudFront. CloudFront is a content delivery network or CDN that delivers content globally with low latency by caching its all edge locations. Use cases include delivering static and dynamic content, streaming video, serving APIs, and enhancing website performance. Integration: integrate the CloudFront with S3, EC2, or on premises servers to cache content closer to users. AWS Global Accelerator. AWS Global Accelerator is a service that improves the availability and performance of your applications by routing traffic through the AWS Global Network. Benefits include performance, reduces latency by routing user traffic to the optimal endpoint. Failover provides automatic failovers across multiple regions for high availability. Use cases include ideal for global applications requiring low latency and high availability, such as gaming, media, and IoT applications. This particular section provides an in depth understanding of AWS cloud architecture, focusing on high availability, fault tolerance, scalability, and the strategic use of AWS's global infrastructure. These concepts are fundamental for designing resilient and efficient cloud architectures and are crucial for the AWS Certified Cloud Practitioner exam. Next, we're going to look at AWS Cloud Adoption Framework. Section 7: AWS Cloud Adoption Framework or CAF. Let's look at the overview of AWS Cloud Adoption Framework. In this, first, we're going to do the introduction to AWS CAF. The AWS Cloud Adoption Framework CAF provides a structured approach to help organizations adopt cloud technologies effectively. It offers guidance for transitioning to the cloud while addressing both technical and business perspectives. The purpose: AWS CAF is designed to help organizations create a comprehensive plan for cloud adoption ensuring alignment between business objectives and cloud capabilities. Some of the key components: AWS CAF is organized into six perspectives, each addressing a distinct aspect of cloud adoption: business, people, governance, platform, security, and operations. Let's go into the six perspectives of AWS CAF. First, being the business perspective. The focus here is aligning cloud adoption with business goals and outcomes, ensuring that the cloud strategy supports the organization's business objectives. The key stakeholders: business managers, finance teams, and strategy planners. Key considerations here is value realization, identifying and measuring the value of cloud investments; business case development, creating a compelling business case for cloud adoption; stakeholder management, engaging and managing stakeholders throughout the cloud journey; best practices, regularly review and update business goals to align with cloud capabilities; use data driven insights to support business decisions related to cloud adoption. Next one, people perspective. The focus: managing change within the organization as it transitions to the cloud, ensuring that staff are equipped with the necessary skills and knowledge. Key stakeholders here are HR, organizational change management teams, and training departments. Key consideration: first, training and certification, upskilling employees to ensure they have the competencies required for cloud operations; change management, implementing strategies to manage the cultural and operational shifts associated with cloud adoption; communication, keeping all stakeholders informed and engaged throughout the transition. The best practices to follow here are: develop a structured training and certification program for cloud skills, establish clear communication channels and feedback loops to manage change effectively. The governance perspective. The focus here being establishing policies and standards to ensure effective cloud governance, including compliance, risk management, and financial oversight. The key stakeholders here are risk management, compliance, finance, and legal teams. The key consideration first being policy development, creating cloud governance policies that align with corporate standards; compliance and risk management, ensuring cloud operations meet regulatory requirements and managing associated risks; cost management, implementing financial controls to manage cloud spending effectively. Best practices include regularly review and update governance policies to adapt to changing cloud services and regulatory landscapes. Use automated tools for compliance, monitoring, and cost management. Platform perspective. The focus here being designing, building, and optimizing the cloud environment. This includes the technical architecture, infrastructure, and services that form the foundation of cloud operations. Key stakeholders: the IT architects, engineers, and developers. Key considerations: infrastructure as code IAC, automating infrastructure provisioning and management using IAC tools like AWS CloudFormation or Terraform; scalability and performance, ensuring the cloud platform can scale to meet business demands while maintaining performance; service selection, choosing the right AWS services to support workloads and business objectives. Best practices include adopt IAC for consistent, repeatable, and automated infrastructure deployment; continuously monitor and optimize the performance and scalability of cloud resources. Next, security perspective. The focus here being ensuring the security and compliance of the cloud environment. This includes identity management, data protection, and incident response. Key stakeholders in this case are security and compliance teams and IT leadership. Key consideration includes IAM, which is identity and access management, implementing least privilege access and strong authentication mechanisms; data protection, encrypting data at rest and in transit, and ensuring data privacy. Incident response, developing and testing a robust incident response plan for cloud operations. Best practices, implement IAM best practices, including the use of multi factor authentication or MFA. Regularly audit and update security controls to address emerging threats. Next perspective is the operations. Managing and monitoring the operations of cloud environment to ensure reliability, availability, and performance is the focus. The key stakeholders in this case is IT operations team, support teams, and service managers. Key considerations include monitoring and logging, using tools like Amazon CloudWatch and AWS CloudTrail to monitor cloud resources and log activities. Incident management, establishing processes for detecting, responding, or responding to, and recovering from operational incidents. Operational excellence, continuously improve operational processes and practices to enhance efficiency. Best practices include implement comprehensive monitoring and alerting systems to detect and respond to issues in real time. Use automation to streamline routine operations and reduce manual intervention. Planning and implementing AWS CAF. First, let's look at the migration strategies and best practices. Now, we look through the 6 R's of migrations. What are they? Rehost, replatform, repurchase, refactor, retire, and retain. So, the first one, rehost, which is lift and shift, moving applications as is to the cloud with minimal changes. Quick and simple, often used for initial cloud migrations. The replatform, which is also lift, tinker, and shift, we're making a few cloud optimization without changing the core architecture of the applications. For example, moving a database to Amazon RDS. Repurchase or drop and shop, moving to a new cloud native product such as switching from a traditional CRM to Salesforce on AWS. Refactor, re-architect, redesigning applications to leverage cloud native capabilities fully. This is often more complex but can result in significant long term benefits. Retire, decommissioning applications that are no longer needed or are redundant. Retain, keep certain applications on prem due to latency, security, or other requirements. Now, what are the best practices for migration? Assessment. Start with a comprehensive assessment of your current environment, identifying which applications are suitable for migrations and prioritizing them based on business needs. Proof of concept or POC. Implement POCs for key workloads to validate the migration approach and identify potential issues before full scale migration. Incremental migration. Migrate in phases rather than a big bang approach to minimize risk and allow for testing and adjustments. Training and enablement. Ensure that your teams are trained and equipped with the necessary cloud skills before, during, and after migration. Optimization. Continuously optimize resources and architectures post migration to ensure cost efficiency and performance. Let's look at some case studies of cloud adoption. We'll go through the real world examples. First one, enterprise transformation. How a large enterprise leveraged AWS CF to migrate and modernize its applications, resulting in cost savings, improved agility, and enhanced security. Startups. How a startup used AWS CAF to build a cloud native architecture that scales with its growth, allowing it to quickly bring new features to market. And public sector. How a government agency adopted AWS CAF to meet compliance requirements while modernizing its infrastructure and services. Some of the lessons learned is stakeholder alignment. Ensure that all stakeholders are aligned with the cloud strategy from the outset to avoid delays and conflicts. Flexibility. Be flexible in your approach to cloud adoption as requirements and priorities may change during the journey. Continuous improvement. Cloud adoption is an ongoing process. Regularly review and refine your cloud strategy, processes, and architectures. Now, this section provides a detailed overview of AWS Cloud Adoption Framework CAF, guiding organizations through the process of adopting cloud technologies. It covers the key perspectives of cloud adoption, migration strategies, and real world examples to illustrate how AWS CAF can be implemented successfully. These concepts are vital for organizations transitioning to the cloud and are part of the AWS Certified Cloud Practitioner exam. Next, we are going to look at preparation and practice. Section 8, Preparation and Practice. We'll start with practice exams and quizzes. Now, what are the importance of practice exams? It helps you familiarity with exam format. Practice exams help you become familiar with the format of the AWS Certified Cloud Practitioner exam, including the types of questions, time limits, and exam structure. This familiarity reduces exam day anxiety and helps you manage your time more effectively. Identifying knowledge gaps. Taking practice exams allows you to identify areas where you may be weak or need further study. By reviewing your answers and understanding why certain responses were incorrect, you can focus your study efforts more effectively. Building confidence. Regularly scoring well on practice exams can boost your confidence and ensure that you are well prepared for the actual exam. Where to find these practice exams? First is AWS official practice exam. AWS offers an official practice exam for cloud practitioner certification. This exam is designed to mimic the actual exam and provides a realistic testing experience. Available through the AWS training and certification portal, it includes a mix of multiple choice and multiple response questions. Third party practice exams. Platforms like websites like Udemy, WizLabs, and ExamPro offer extensive practice exams that closely resemble the format and content of the actual AWS exam. The features of these platforms often include detailed explanations for each question, allowing you to understand the reasoning behind the correct answers. There's also community and study groups. There's forums and discussion groups. Engage in AWS certification forums such as Reddit, Cloud Guru forums, or LinkedIn groups. These communities share practice questions, tips, and study resources. Study groups. Join or form a study group with peers preparing for the same exam. Group discussions can help clarify complex topics and provide diverse perspectives on potential exam questions. Analyzing practice exam results. Reviewing incorrect answers. After completing a practice exam, thoroughly review all the incorrect answers, understand why your answer was incorrect and why the correct answer is right. Look for patterns in the types of questions you're missing. Example, questions on specific AWS services, security, pricing. This can highlight areas where you need further study. Tracking your progress. Keep a record of your scores on each practice exam. Tracking your progress over time helps you see improvements and identify any persistent areas of weakness. Set a target score for practice exams that is higher than the actual passing score of the certification exam to build a buffer and boost confidence. Review and study strategies. Review key concepts and services. Revisit core services. Focus on the core AWS services that are frequently covered in the cloud practitioner exams such as EC2, S3, RDS, VPC, and IAM. Use AWS documentation, white papers, and rewatching course videos to enforce your understanding of these services. Summarize key topics. Create summary notes or flashcards for key concepts such as cloud computing models, IaaS, PaaS, and SaaS, AWS Global Infrastructure, regions and AZs, and pricing models which are pay as you go and reserved instances. Regularly review these summaries to keep key information fresh in your mind. Time management and exam tips. Time allocation. The AWS Certified Cloud Practitioner exams allow 90 minutes to complete 65 questions. Allocate approximately 1 to 2 minutes per question. If a question seems difficult, flag it and move on. Return to flagged questions after you answered the easier ones. Reading questions carefully. Carefully read each question and all possible answers before selecting your response. AWS exam questions often include details that are crucial for choosing the correct answer. Watch out for qualifiers like most, best, least, and only, as they can significantly affect the meaning of the question. Elimination technique. If unsure of an answer, use the process of elimination to narrow down the choices. Remove any options that are clearly incorrect and make an educated guess from the remaining options. Remember, there is no penalty for guessing, so answer every question. Final review section. Recap of important concepts. Let's look at some of the key AWS services. Ensure you have a solid understanding of the foundational AWS services, including their use cases, benefits, and pricing models. Focus on services like EC2, S3, Lambda, VPC, IAM, and RDS, which are frequently tested. AWS Global Infrastructure. Review the structure of AWS Global Infrastructure, including regions, availability zones, and edge locations. Understand how these components contribute to fault tolerance, high availability, and performance. Security and compliance. Revisit the AWS shared responsibility model, IAM best practices, and key compliance frameworks supported by AWS like SOC, ISO, PCI DSS. Understand how AWS services help maintain security and compliance, such as through encryption, access control, and monitoring. Last minute tips and tricks. Stay calm and focused, get a good night's sleep before the exam. Being well rested can improve focus and cognitive functions. Eat a light meal before the exam to ensure you have enough energy without feeling sluggish. Technical preparedness for online exams. Ensure your testing environment is quiet, well lit, and free from distractions. Test your internet connection, webcam, and microphone to avoid technical issues during the exam. Have a government issued ID ready for verification before the exam starts. Mindset and attitude. Approach the exam with confidence. If you are prepared thoroughly, trust your knowledge and instincts. If you encounter a difficult question, remember that it's okay to take a deep breath, refocus, and tackle the question with a clear mind. Some of the supplemental resources that you can look for are AWS documentation and white papers. Regularly refer to AWS official documentation white papers for the most accurate and up-to-date information on AWS services. Some key white papers to review include the overview of Amazon Web Services, AWS Well-Architected Framework, and how AWS pricing works. For AWS Cloud Practitioner Essential course, this official course from AWS covers all the topics needed for the exam, includes video, demos, and hands-on labs if you want to look at more. Consider going through the course again, especially sections you find challenging that you did in this particular section. AWS Free Tier hands-on practice. Use the AWS Free Tier to gain practical experience with AWS services, setting up EC2 instances, S3 buckets, or VPCs in real environment will reinforce your theoretical knowledge. But just FYI, 90% of the people who have taken this exam without AWS Free Tier have cleared the exam. Community forums and study groups. Join AWS certification forums and study groups to exchange tips, ask questions, and stay motivated. Engaging with a community of learners can provide support and additional resources as you prepare for the exam. So, this last section outlines a structured approach to final preparation and practice for the AWS Certified Cloud Practitioner exam. It emphasizes the importance of practice exams, reviewing key concepts, and implementing effective exam strategies to ensure success on exam day. So, you can go ahead and set up your exam date and let me know in comments how it goes, if you cleared or not, or if there was something additional that I can add to. And if you have questions, leave them in the comments. Thank you.